Hi, welcome to an ESP32 tutorial from Robojax. In this video we are going to use the SunFounder's ESP32 with extension board and lithium battery to run this plant monitor project. This is a combination of 5 projects that we have learned before. We are using L293D to control and run this centrifugal water pump. Then we are using a push button to turn it on and off. We are using DHT11 to measure the temperature and humidity. And we are using LCD screen to display temperature and humidity. We are using soil moisture sensor. We are using LDR to measure the light. Combining all this together so we can monitor our plant. This is a very interesting project. I'm going to go step by step, so we are going to learn it. Let's get started with this. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. We have separate project for L293D to control DC motor or centrifugal water pump. We have explained the wiring and code fully. We had separate video for DHT to measure temperature and humidity. And then we used this to display temperature and humidity on the screen. We had separate video on how to use the push button with ESP32. We had full video on LDR to control and understand the amount of light for day and night. And then we have separate video for the soil moisture sensor, which we explained it fully. And we used this LCD screen multiple times. The project is now running directly with a provided lithium battery as part of this SunFounder's ESP32 learning kit, which comes with all these components. Now we are going to combine everything together to run this, and as you can see it shows humidity and temperature, and then it shows moisture amount and light continuously. And here, as you can see right now, it shows moisture. If I hold this, amount of moisture based on capacitive value is changed to 1500, and the same way the temperature will show here as it changes. Come to this page, docs.sunfounder.com, scroll down until you see ESP32, then click on ESP32 starter kit main. On the left side, click on Arduino user and scroll down to 6.6 plant monitor. This is the documentation for today's lesson. It gives you some information as how this project works. I'm going to explain it fully. We need ESP32 extension. We need ESP32 board, ESP32 extension camera board, breadboard, jumper wires, and we have DHT11. We use LCD, we use a centrifugal pump, and we use L293D motor driver. We will use a push button. We will use photoresistor, and we need resistors with soil monitor. So far we have explained all of this one by one, and if you need information, you just click on each item, you will get full information. Here is the full schematic for today's lesson. We have LCD 1602 with a 2 wire will be connected to 2122. We have DHT11, 1 wire will be connected to ESP32, and L293D, 2 wires will be connected to our ESP32 to control the motor. And then we have this portion is photoresistor or LDR, so 1 pin is connected, so we are reading the value for this. And then this is a soil moisture sensor, which we have separate video for this. And then we have a push button. As you can see, we have multiple projects all in one, and there is some explanation. This is the actual wiring diagram, which I'm going to explain it in the wiring section. The code will be explained in the code explanation section. I will provide you the link if you want to have a look at this. Because this project involves so many projects all in one, I'm going to break it down into pieces, making sure everything works. So first, I'm going to use this push button with L293D. So we push this button and the L293D will work. Then I'm going to add this humidity and temperature sensor, L293D, making sure that we can read a value on the serial monitor. Then I'm going to add this LDR and making sure that we can read the value when that light intensity changes. Then I'm going to add the soil moisture sensor, and we will read the value. Finally, we will add the LCD, so the LCD will display whatever information that is needed from our project. We have to pay attention that the push button is connected to pin 32, and pin 32 on ESP32 has a 1 kilo ohm pull down resistor. So this push button is always connected to low at this point. This point is always connected with 1 kilo ohm resistor to the ground. So when you don't push it, it's always low, and when we push it, we read high. So keep that in mind. For the wiring, we have to pay attention that LCD is connected to 5 volts, and then L293D motor driver is connected to 5 volts. The rest are all connected to 3.3 volts. Moisture sensor, 3.3 volts, DHT, 3.3 volts, but it works with 5 volts. This also works with 5 volts, but this photoresistor or LDR, we will connect it to 3.3 volts. Now let's do the wiring for L293D. I'm inserting the L293D. Pay attention to this dot. This is pin 1 and then pin 8. I've already explained it, so pay attention to this. And we're going to insert it somewhere on the left side because we don't need any other component here. So just put it somewhere that legs should be on the other side and this side, and push it. Because we have already used it before, it's easy. If this is your first time, you just need to push it before push the pins down before pushing it to the breadboard. I'm using this type of wire because I want this one to look clean for you on the camera, but you can use your the wires that comes with the project. So from here, let's connect from pin 1 to pin 16 connected. And because this, we're going to use this red as our VCC or power supply, and then the blue will be our ground. So I'm using it now here, and we have 16 to 1 and all to the positive. If I show you here, you will see that pin 16 is connected to pin 1 and it is connected to pin 8. But here from pin 8 also there is another wire, which I'm going to do it. I'm using a short wire, so from pin 16, getting it like that. By the way, I'm using this type of jumper wires. So I'm using very short wire and connecting this pin 1 to VCC. So now this is connected, and using pin 8 to the VCC, to the red line, that is connected, and then pin 4 is connected to the ground. Here you can see pin 4 is connected to the ground. So let's get pin 1, 2, 3, and then 4. I'm connecting it to the ground. Like that. For this, we need to connect one yellow and one green wire to 27 and 26. And I'm connecting green wire from pin 2 to 27. Let me show you here. From 2 it goes to 27 using green wire. I've connected 27, 26 to these terminals. You can connect it to these pins or maybe directly to the ESP32. So 2 to 27, and my green is 27. It goes to pin 2. Anywhere is okay in here. And then pin 7 goes to 26 with the yellow. The last pin is 8. That is pin 7. And here is my centrifugal water pump. I've already connected this pipe, and we have 2 wires. The wire does not matter. It will be connected to pin 3 and 4, 5, 6, 3 and 6 in here. This is our M is the motor. It connects to pin 3 and pin 6. So let's just connect it to pin 3 and 4, 5, and then 6. Doesn't matter where. And here, lastly, we connect 5 volts from here, these 2 terminals, or from here, positive and negative. Remember, the USB is this way. And we connect the red to the red line, to the positive, and ground somewhere on the ground, and it should work fine. Now we are going to run this code 4.2, but we are going to change these pins from 13 and 14 to 25 and 26. So 4.2, pumping. File, open, go to 4.2. And here 4.2, pump, click select and click open. This is the code. So we need to put here 20, it's 27 and 26, the 2 pins. So let's change this to 27 and then 26. The order here doesn't matter even, and the board is connected, the port is also connected. Click, upload the code, connected the battery. Let me turn it on. We should be able to hear a buzz. I'm going to put the microphone. The pump is now working, and this code is running. I've changed it for 5 seconds to be high and then 2 seconds low. So in your code it might be 2 seconds, so it doesn't matter. But the code, the pump, this will turn on the pump and this will turn it off, which I've explained it fully. Let's insert our push button around 35, so we have room for this DHT11 around 35. Insert it, get a wire and connect the right side to the 3.2 to the red line. like that. And then for the push button, get a wire and connect it to pin 32 from the left side. Here in the diagram also, here on the push button is also connected to pin 32 on this diagram. And I connected a wire to pin 32, blue wire, connecting it to the left side. This is the push button pin for the pump. I've just added the pin 32 here for the push button pin with new variable. In this line we have defined using pin mode this push button pin as input. Inside the loop, instead of running this, we put a conditional statement and we say if digital read pin, using digital read, we are reading the pin. If the value is equal high, these two equals are for comparing. So if that is high, which means it is pushed, then the motor will rotate. You see one pin is high, the other pin is low. Else, we set both of these to low, so the motor is off. And let me disconnect this. Now let's turn it on. Here is the motor. And when I push this, the motor rotates. Let me put out close to the microphone. I'm pushing it now. Release, push. As you can see, this is working. We are going to run this 5.13 to just make sure that DHT11 works. In our wiring, this is connected to pin 13. Now for the L293D, for this DHT, we are connecting it to 3.3 volts, and let's connect it somewhere on this empty spot. For the L293D, the left pin will be connected to 3.3 volts in here. But we are also expanding this 3.3 volts to the other side. We are going to have 5 volts on this side and 3.3 volts on this side. For that, let's create a pin here from the left pin. Let's connect a red wire and connect it to the red. So we are connecting this to 3.3 volts. And from this 3.3 volts, get a wire and connect it to the left pin. So this is now 3.3 volt is coming to the left pin, and it goes to the other side, and it comes to the push button. So we got 3.3 volts there and 5 volts here. And then from the second pin, it is connected to the third pin from the top. This DHT is connected to pin 13. 13 here. I'm connecting this wire to pin 13. And connecting it to the second pin. Now DHT11 is ready. Open 5.12, file, open. Now let's open 5.13 DHT. And we have multiple. So open the 5.13 DHT. Change this to 13. Everything is ready. Let's just upload it. And here, as you can see, we are reading temperature and humidity. So our temperature sensor is working. Now let's see what happens. I forgot to mention that if I remove it, let's see, we are reading failed to read from DHT. So now let's do the wiring for the capacitive soil moisture sensor, and we are going to connect it to 3.3 volts. Here is the wiring for the soil moisture sensor at the bottom, this one. Here I'm connecting a male to male wire with the same color, and this side is the wires. Now I'm referring to this. So This is our ground. Connect the blue is our ground, the blue side. Connect that brown to the blue. And then we have the red. The red is 3.3 volts. Let's connect it in here. And then orange is the signal pin, which goes to pin 14. And moisture sensor, the yellow wire is connected to pin 14 in here. Now we are going to open the 5.9. Now open 5.9 moisture. To test it. And our moisture sensor is connected to pin 14. Make sure to update the code if it's not pin 14. It is now here pin 35. I'm changing it. Here it's pin 35. I'm changing it to pin 14 and uploading the code. And as you can see, we are reading some value here. If I touch it, the value is changing to around 1000. And if I remove my hand, it will be around 2000. So that's the effect of capacitive change. This capacitive soil moisture sensor is working. Now let's do the wiring for our LDR. Get a 10 kilo ohm resistor as shown here. Let's connect the LDR somewhere on the breadboard, the 2 pins like this. Get the 10 kilo ohm resistor and connect it from the left pin to the ground, to this blue. I'm connecting it from here to the blue line. So it is connected now. This pink wire is for the soil moisture sensor. I already connected it there, so I don't need to connect it here. Just connect one wire from here to the 3.3 volts. A red wire, connecting it to the left pin, and then connecting it to the 3.3 volts, which is on this side. That's our 3.3 and this is our 5 volts. And finally, we will connect this pin. This is this pin, which is connected to pin 35. A blue from the place where the resistor and LDR are connected to pin 35. Pin 35 is the fourth pin from this side or connected here. So the LDR is completed. Now let's open the 5.7, feel the light code. Go to File and 5.7. 5.7, feel the light. Open it. To this diagram, it is connected to pin 35. And feel the light, which I just opened, it is also pin 35. Let's upload the code. And as you can see, we are reading the light value. Here, if I bring my hand, the value changes significantly. It's being reduced and increased. So our LDR is working. Wiring for the LCD. I'm going to use this schematic. So the ground, the top line is connected to the ground. I'm connecting one of the ground on the breadboard, the top line, and then the next one is this white one is 5 volts. That's connected to 5 volts. The second line here, the red, is 5 volt. And this SDA, the gray, is connected to 21 and this to 22. So 21, 22. Let's get gray. So 21 is here. And 22 is second from the last. Now the wiring is fully completed. Now let's open and scroll down at 6.6. 6.6 plant monitor. Double click to open this folder. Click and select, and then click to open the file. Because we have combined all the code, this is for DHT for the temperature sensor, this is for the LCD screen, this is the library for the LCD screen. Pin 13 is for the temperature sensor for DHT11, pin 14 for the moisture sensor. These are all variables defined as a constant. Pin 35 is for the LDR or light pin. These two pins are for the motor, and then pin 32 is for the push button. Here we are defining our temperature sensor, DHT11. If you have DHT22, just change it to 22 and it will be just fine. And here we are creating an instance of this DHT class, and we pass the type and the pin. So this is for the DHT. This is for the page of the LCD, which is updated, and then using LCD crystals, liquid crystal library, we create this object. We pass the I2C address. This is number of lines, a number of characters, 16 characters, 2 lines. I've already explained all this. This is for the serial monitor, initializing the temperature sensor, initializing the LCD, defining pin for the motor, and defining pin for the push button. Inside the loop, first we read the humidity and store it in a variable called humidity. We read the temperature as Celsius, store it in this variable called temperature, and this is to take care of the error with the temperature sensor. We use clear, lcd.clear, to clear the screen, and this is called modulus. We get the page and we add it and we divide it by 2 so we can find out if it's page 1 or page 2. So the result of the division will be that the modulus, we get either 0 or 1. And this, if the value is 1, all this code will run, which means it shows humidity and temperature. So this is, and if it is 0, the result of this calculation is 0, then we print the moisture from the moisture pin, and then we also print the light. This is just printing it on the serial monitor using digital. When you press the push button, if the push button is high, then we turn on the motor, else we turn it off, and we have 2 seconds delay. So every 2 seconds all the information will be updated. I just clicked to upload the code. Now it shows 0 for the, this is just for push button, nothing else. And in case if you did not follow my previous lessons, let's clarify this, that in the serial monitor have been defined at 115,200. This number here must match when you open the serial monitor. If you put something else, it will not be readable, so make sure it's 115,200 so you can read the value. When I press the push button, as you can see here, On the screen we are reading 1. I'm pushing it so you can see it with one hand holding mouse. So the motor will run, and then if I release it, it will be turned off, and the screen is constantly measuring the moisture, light, temperature, and humidity. I've uploaded the code now, and we see the humidity and temperature and also amount of light. Let me cover this. As soon as I cover it, pay attention here, the light is around 2600. If I remove my hand, the amount of light is now 4000. So we are reading it very well. And also the capacitive touch, if I hold it, 1600, it says moisture 1800, and if I remove my hand, just wait, 2500. So we could use those values practically, which I've explained it in a previous lesson, to take some action based on this. And once you detected that the amount of water is low, you can use a push button to turn on the centrifugal motor control water pump to water your project, and once you remove it, the water will stop. This will spill a lot of water on this project. I have tested it separately, so I'm not going to repeat it in here. Just watch the video for the centrifugal water pump.